Hey guys, good news. I finally got my tablet working. So you get to hear Mrs. Callis again. I know you're excited. All right, so let's review. First off, we have our angle triangle inequality, or not our angle triangle, our remote interior inequality, right? So any exterior angle, which is obviously this guy right here, has to be greater than our remote interior angles, right? So 2x plus 5 is an interior angle. That has to be less than this exterior angle here, right? Interior remote less than exterior. However, this is an exterior angle to this remote interior angle. So this guy has to be a greater than 87, right? So here's the exterior angle that we're talking about first. This one is going to be greater than this interior angle, but then this is also an exterior angle to this angle, so it's going to be greater than 87. And now I've set up a nice little proportion, which I can, or a rate inequality, so I can solve that. So let's subtract 5 from all sides, giving me 82 over here, and divide by 2. So x has to be less than 80, but greater than 41. Okay. Also, remember, this one does have to be less than 180, but it's already less than 180 when it's less than 165, so we don't need to worry about that restriction. All right, let's move on. So we're doing 5.6 today, which is proving quads parallelograms. So students will be able to use one of the 6 theorems to prove that a quadrilateral is a parallelogram. So we're going to be proving some parallelograms. So proving quads are parallelograms, right? So we have a bunch of different ways to do this. One is if both sets of sides are opposite. So if both, oh, look at that, I have animations. So if both sets of opposite sides, or pairs, opposite sides parallel, then we have a parallelogram. Right? If both pairs of opposite angles are congruent, then we have a parallelogram. If, what am I looking for? Oh, both pairs or both sets of opposite sides are congruent, then we have a parallelogram. All right. If both diagonals are bisected, we have a parallelogram. If both consecutive angles are sup, sets of consecutive angles supplementary, we have a parallelogram. And then lastly, we have a special case where if one set of sides is both parallel and congruent, we have a parallelogram. Right? So essentially all 5 of the properties that we know about parallelograms, if those are true, we have a parallelogram. And then this guy is our new one. And if we have one set of parallel sides that are both, or one set of sides that is both parallel and congruent, we have a parallelogram, right? It might help to label this too in your pictures. So like both sets are parallel, right? Or both pairs of opposite angles are congruent. That'll do it, right? Or both opposite sides are congruent. That'll do it. Or the diagonals are both being bisected. That'll do it, right? Or this is going to be harder, 180 and 180. That'll do it, right? Or one set of sides is both congruent and parallel. And again, that's the new case. These can all be proven, right? It's not fun, but they can be. All right, so again, I said that they could be proven. So it says prove if one pair of opposite sides of a quadrilateral are both parallel and congruent, then the quadrilateral is a parallelogram, right? So essentially what we're saying, right, is I have a parallel, or I have a quadrilateral, and it's given to me, right? So we have given that, and let's label this guy A, B, C, D. So we know that AB is parallel to CD, and we know that AB is congruent to CD. That is the given. And we are trying to prove that we have a parallelogram, right? A, B, C, D is a parallelogram. It's a terrible parallelogram. All right, so again, we have parallel here, and we have congruent here. All right, so the definition of a parallelogram is both sets of sides are parallel, right? Both opposite sides are parallel. So what we need is AD to be parallel to BC, yeah? And if we can get some of our angle relationships here to help us with that, that'll do it, right? So if we can get AD to be parallel to BC, again, we'll have a parallelogram. So essentially, we either need to get an angle pair that will prove parallel lines. Yes? All right. So if we have these two guys parallel, right, we could either use AB as the transversal, or we could use DC as the transversal, right? And therefore, if I can prove that angle D is sup to angle C, then I can prove that I have parallel lines, because then we have same side interior angles that would be supplementary. All right, so we're going to use our parallel lines that we already have and go ahead and do that. Or you know what, let's not. Let's make a triangle. And we'll make some diagonals. So let's prove some congruent triangles, and then we can use the diagonal to help us prove it. So if I draw that diagonal DB, right, then I can use alternate interior angles. So if I get ADB congruent to DBC, then I've got alternate interior angles. So I'm going to get these triangles congruent that way, and we'll do it that way. Much easier. Okay, so we're going to prove these triangles are congruent first. That's the easy part. So we already have that AB is congruent to CD, so we have a side. We have my favorite, first step given, right? I'm cheating. I got my math degree. All right, let's do my favorite property first. We know that BD is congruent to BD by the reflexive property. So now we have another side. And we have alternate interior angles are congruent because, again, we have one set of parallel sides already. So I can say that angle ABD is congruent to angle BDC by alternate interior angles are congruent. Angle BDC. If parallel lines, then alternate interior angles congruent. All right, so now I have two congruent triangles by side angle side. ABD is congruent to triangle CAD DB by side angle side. And if the triangles are congruent, then everything is congruent by CPCTC. So let's make the angles we actually need to be congruent to prove parallel lines. So now I'm going to say ADB is congruent to DBC by CPCTC. ADB is congruent to CBD by CPCTC. And if ADB is congruent to CBD, right, trace these angles out, we have parallel lines because alternate interior angles are congruent. So we can say AD is parallel to BC by alternate interior angles congruent, then parallel lines. And lastly, right, run out of room, I'm going to come up here. If both sets of sides are parallel by definition of parallelogram, we have a parallelogram. So number 7 is A, B, C, D is a parallelogram. Both sets of sides parallel, or definition of parallelogram. All right, so again, when I drew the picture, I just threw in that diagonal. If you put auxiliary line in, you could, but I'm just going to say that was already there. Don't tell anyone. All right, again, we're not going to prove all of these properties are true, but it's pretty easy to do using congruent triangles. And yeah, so let's move on. All right, so a quadrilateral in a coordinate plane is a little trickier to prove. So these are going to be some practice problems that we're going to do throughout this unit, but let's start with one. So the first step in these guys is we're just going to graph. So -10 to +6 is P, and then Q goes to 2, 6, and then we have S, which is -7, -4, and we have 5, -4. All right. Should have probably labeled these Q, S, and R. All right. So we have just drawn a quadrilateral, and we want to prove that it's a parallelogram. Now, there's a couple of properties we can do to use to do that. One of the easiest ones is slopes, right? Slopes will tell us everything. So we could find distances between all these sides and say opposite sides are congruent. We could find the diagonals, midpoints, and determine if they're being bisected. Again, these are all different properties that you could use. But again, we're going to use slopes for everything because it will determine all of these shapes. So we're going to find the slopes of the opposite sides. Yeah? So there's a couple of ways we can do this. We can use our slope formula. So change in y over change in x. Or we can count it because it's a graph, right? So I don't know how many of you guys remember your Mr. Slope Man, right, from Algebra 1. But we have a slope that's going upwards is a positive slope. We have a slope that's going down is a negative slope. We have a vertical line, which is an undefined slope. And we have a horizontal line, which has a 0 slope, right? I like to think of it as if you're going skiing and you're on a slope that is flat, right? If you're on a flat surface, you're going 0 miles an hour. If you are skiing and you fall off a cliff, that's a vertical cliff, your body will be undefined at the bottom. I know, creepy, but you'll remember. Anyway, so we're going to find the slopes here. So SR is a vertical line, which according to our slope in is a 0 slope. And PQ is another horizontal line. So our slope is again 0. So we know that PQ is parallel to SR. Yeah? Opposite, same slope. Same slope. So there's one set of parallel lines. Now I'm going to find the slopes of QR and PS. So rise over run, right? So we can count how many up and how many over, or you can use the slope formula, but I'm just going to count here. So we go up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 1, 2, 3 to the left, which is a negative, right? So we went up through 10 to the left 3. So my slope here is going to be 10 over negative 3, or negative 10/3, right? We can just put that negative out in front. I'm going to do the same thing between SP. So we're going to go up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we went up 10, and then over 1, 2, 3. Again, that's a negative. So our slope is negative 10/3. And look at that, same slope, parallel lines. So PS is parallel to QR. Same slope. We have opposite sides parallel. So this is a parallelogram. Why? Opposite sides parallel. Okay. As we continue through this unit, we're going to be adding more properties to our quadrilaterals in order to eliminate different shapes along the way. The very first one is our parallelogram. So we are good to go. All right, let's do a proof to wrap this lesson up. So it says that CAR is an isosceles triangle with a base of CR. It says angle C is congruent to angle K, and AC is congruent to BK. All right, so we're trying to prove that we have a parallelogram here, which obviously we need some relationships. So we're going to see what properties we can use to prove a parallelogram. Again, I'm going to cheat here and just write given to save myself some room, but you will not because you don't have a math degree. All right, so it appears that I have one set of sides that I can get congruent, right? And if I can get one set of sides congruent, I'm going to try and aim to get them also parallel, because then we can use our property. If one set of sides is both congruent and parallel, we're good to go. All right, so let's use our given first. I have an isosceles triangle, right? So I know that AC is congruent to AR, so I'm going to use that property or definition, right? So AC is congruent to AR, and that's definition of isosceles, right? Okay, well, we already have it marked in the picture, but if AC is congruent to AR and AC is congruent to BK, we can use substitution or the good old choo-choo train property and get AR congruent to BK, because now we have one thing done in our proof that we are trying to get to. So AR is congruent to BK by a transitive or substitution property. Either one will work here, right? So again, our goal here is to get one set of sides congruent and parallel. We have one set of sides congruent, now we need the parallel. So let's use some angles, because that's how we prove parallel lines. All right, well, we know C is congruent to K, yes, but we can also get C congruent to R by the isosceles theorem, right? So I'm going to say angle C is congruent to angle ARC by if sides, then angles. And if C is congruent to K and ARC is congruent to C, then we can say ARC is congruent to angle K. And now, if we trace these congruent angles, I have corresponding angles congruent, and I have parallel lines, right? So I know that AR is parallel to BK. Whoops, sorry, I forgot to put that reason there. Whoops. That's, again, transitive or substitution. Got ahead of my health. Woo. So we used transitive or substitution to get the angles congruent as well, right? But now we have parallel lines because corresponding angles are congruent. So we have parallel lines. And now we have one set aside, both parallel and congruent. So we have a parallelogram. Parallel and congruent. So we have parallelogram. All right, so again, when you're trying to prove a parallelogram, go through the 5 ways we have to prove them. 6, if you count our special location, right? So go through those 6 properties and then determine which one you can get. Okay, one more proof. I thought I was done. All right, so it says A, C, D, F, so this big guy is a parallelogram, and then it tells me AFB, so this angle up here, is congruent to ECD, okay? And we're trying to prove that FBCE is a parallelogram, okay? All right, so let's use our given. Again, I'm going to cheat. You cannot. All right, so it appears that we're probably going to use some angle relationships here, right? If I'm trying to get this parallelogram to be a parallelogram, yeah, and I have some congruent angles already, I'm going to think, all right, I need either parallel lines or congruent angles, yeah? All right, so I know that this is a parallelogram, the big guy. Therefore, I already have that FE is parallel to BC because FD is parallel to AC given that it's a parallelogram, right? So we know these guys are parallel. We also know that these 2 sides are parallel as well because we have a parallelogram. So I'm going to use that, okay? So let's say FE is parallel to BC, or FD is parallel to AC. It doesn't matter what 2 points you pick on that line. Definition of parallelogram, all right? So these are the sides of the parallelogram that we are given. Therefore, those lines are parallel. You want to make these lines instead of line segments. That's probably more accurate. Okay, so if those are parallel, we have a transversal here, right? Well, if that's a transversal, this guy here and this guy here are same side interior angles. I believe that means they are supplementary, right? And the same thing is here with this transversal. These are parallel lines. That means these are supplementary, right? So let's go ahead and put that in the proof. Oops. So angle EFB is sup to angle FBC, and angle FEC is sup to angle ECD. Parallel lines, same side interior angles, sup. If both sets of same side interior angles are supplementary, we have ourselves a parallelogram, my friends. So FBCE is a parallelogram, both consecutive angles, sup. And we're done. Now, there's a lot of different ways you could have gone about that. You can actually use a subtraction property to get these set angles opposite that are congruent, and then we can use some angle relationships to get angle B and angle E congruent. That seems like a lot of work to me, though. This one was much shorter. I like to go short. All right, there's your homework, page 252, number 2, 3, 5, 6, 8, and 12. Have a wonderful weekend, and we will see you Monday.